Management from UK and an MSc in Maritime Education and Training from World Maritime University in Sweden. He is currently pursuing doctoral studies. His experience is spread across ship operations, ship design, maritime consultancy, and maritime education and training. Mr. Sudhakar went out to sea as a junior engineer in 1975, having sailed for nearly 15 years on merchant ships. He became a chief engineer in 1991. He joined National Ship Design and Research Center of NSDRC in Visakhapatnam. Subsequently, he served as vice president and head of marine practice in Infotech Enterprises and as country manager in DNV Software. More recently, he established and headed the IR Class Academy of Indian Register of Shipping. He is currently a member of the Academic Council and Planning Board of IMU. And today, the co-chair will be Captain Inderveer Solanki. Okay. Captain Inderveer Solanki, a master mariner with post-graduation degree in maritime affairs from World Maritime University, Malmö, Sweden, and presently pursuing PhD from IMU Chennai. He has commanded ocean-going ships for 10 years. He worked for 15 years as Vice President, Applied Research International Private Limited, and led the development of human resource for the merchant marine and inland waterway transportation sector. He has assisted state governments on Inland Water Authority of India, Government of India in drafting rules, regulations, and policies for IWT sector from 2014 to 2019. He was senior consultant, Jalmarg Vikas Project, IWA project, World Bank project for augmentation of capacity of Ganga, Bhagirathi River Systems, National Waterway 1, IWAI. At present, he is providing need-based consultancy to the World Bank, MOI India Private Limited, MOL India Private Limited, and Param Mitra Coal Resources, Indonesia for inland waterway transportation. He is honorary chairman of the Nautical Institute, India branch, a member of Society of Naval Architecture and Marine Engineering, and associate member of Insurance Institute of India. So, while I give the floor, let me also introduce today's speaker. The speaker is Professor Pawan Kumar. Professor Pawan Kumar is trained.
Sir. First, Yoni.
I didn't have sir, so I have to only introduce yourself.
Okay. So give him Noni.
Okay, I'll tell his name, but
Noni, he is from Tanzania, NIT Warangal. He is a professor in NIT Tanzania, South Africa. Okay, he did his masters from NIT Tanzania and MTech from Andhra University, Visakhapatnam.
Okay, so that is what Professor V.S. Prasad sir has told. So he has studied under him MTech from Andhra University. Dawson Navini, he is from South Africa. His English may be a bit slow. He may be little slow, but he is giving a lecture on radiated underwater noise. Same, sir?
No. Second one.
Second one is radiated underwater noise.
No. Okay, right, the first one.
It is on concept design cycle 10,000.
Yes. That's
Okay.
correct.
Okay. A concept design cycle 1000 DWT multipurpose cargo vessel using ship design tools. So he is Department of Transportation Engineering and Technology, NIT Tanzania. So now Mr. Noni has been trained under Professor Dr. VVS Prasad, who is head of the Marine Engineering Department, from the College of Engineering, Autonomous Andhra University, Visakhapatnam, the oldest college. Professor Prasad sir is BE in 1995 from Andhra University Mechanical Engineering, MTech from IIT Kharagpur 1999, and PhD from Andhra University Mechanical Engineering in 2004. He held various positions. Now he is the head of the Department of Marine Engineering, College of Engineering, Autonomous Andhra University, Visakhapatnam. And he has written 5 important books, and he has written 98 papers, which are published in several journals across. And the most important thing for a professor is how many people are awarded PhD. So he has awarded
8 members awarded, sir.
8 PhD awardees. This is what the International Council counts. Thank you, sir. So I request Noni to proceed. Before that, I request our chairman, sir, and our secretary, sir, to invite all the guests, sir. Sir, secretary, sir.
Thank you, Sir Nanagaru, the convener of the event. I welcome today's chair, URP Sudhakar Garu, and Captain RG Bambot, and the speakers, Dawson Neoni, Dr. VVS Prasad Garu, Professor GVV Pawan Kumar, and Captain Nilesh Kalyanpur. And next session, technical session today, second session, the chairing is Dr. K. Sista and co-chair Engineer S. Suryanarayan Garu, and Mrs. Irene Andre Paul, and Robert Tomli Jovovic from Croatia, and other panelists today. Also the session chair for the panel is Dr. Bhaskar Bandarkar Garu, and chairman co-chair is Professor Dr. Ramana Naik, and the speakers of MIL partners and others, that is Professor I.S. and Raju, Professor Arulavel Sriram, Anubhuti Yadav, and Professor Dr. V.V. Prasad and Ravi K. Sista. These are the panel speakers. And I welcome you, sir, all of you for today's program of this All India two-day seminar, Development of Minor Ports for Internal Transport Management in the Regional Waterways and Canal System. And on behalf of the Telangana State Center and on myself, I warmly and heartily welcome all of you to this program, and I hope all this you will enjoy the speakers talk, and the subject is so good, wonderful subject today. I've gone through the 3 of the first session: concept design cycle 10,000, DWT multi-purpose cargo vessel using ship design tools, to be delivered by engineer Dawson Neoni, and radiated underwater noise from fishing vessels on ambient levels, to be delivered by Professor GVV Pawan Kumar, and the COVID-19 pandemic and seafarer endurance for work. More work is Captain Nilesh Kalyanpur. So I invite you, sir, all of you, to this wonderful 2-day seminar, and I hope you will also enjoy, and at the same time the participants will enjoy your talk. And right now I hand over to our Honorary Secretary to invite Mr. Dawson Aini for continuing his lecture. Thank you very much. Secretary Garu.
Sir.
You can invite Dawson Naini to continue his, to start his lecture.
Yes, sir. Good morning to all of you, sir. So I request Yoni, sir, to proceed with your presentation in this excellent webinar, sir. So I welcome you, sir, once again. Please, sir, proceed with your presentation, sir.
Sorry, sir. Actually, in the earlier list was not there. Today's session co-chair is Captain Indravir Solanki Saab, Master Mariner, Honorary Chairman, Nautical Institute, India branch. I welcome you, sir, Solanki sir, for this program. Thank you, sir. Second session. Sir, may I request Dawson Naini to kindly deliver the lecture, sir. Is he available?
Yeah, he's available, sir.
Okay. Just
Hello, Noni. Start your presentation.
He can start his screen sharing, share the screen. Is he able to get net connection?
Sir.
Mr. Noni?
Sir, Noini have not yet joined, I think, sir. Please check, sir. There may be net problem, I think.
good morning, President. How are you? Sir, just actually I was in that marine introduction welcome for the second. That's why I didn't get it. First March, we have the endowment lecture. I would like to invite.
Sir, starting may have to be done by Pawan Kumar because Noni must not have been given a speaker this thing entry.
Endowment lecture of J. Purushottam.
Noni, his phone number and email are not given, so they must not have given him an entry.
Local man will be speaker, mostly IAS and also will be.
And మామూలుగా ఎంట్రీ అవ్వచ్చు సౌత్ ఆఫ్రికా అక్కడి నుంచి కనెక్షన్ అసలే ఆఫ్రికన్ కంట్రీస్ అన్ని అంటాం చెప్తాను వేరే లైన్ లో ఉన్నారు పవన్ ఉన్నాడు ఆయన ఎక్కడ ఉన్నాడు ఆయన కనిపించడం లేదు
Sir, Surnaran Garu.
సార్
Sir, please share his presentation, sir. May I send his presentation? అతనికి అక్కడ నుంచి షేర్ అవ్వట్లేదట.
ఓకే ఓకే ప్లీజ్ గివ్ ది ప్రెజెంటేషన్ బై
Sharing
ఈమెయిల్
అవ్వట్లేదట, అక్కడ share అవ్వట్లేదట.
తెలంగాణ ఎస్సీ ఐఐ తెలంగాణ ఎస్సీ లేదా నా ఈమెయిల్ కి ఇచ్చినా సరే నేను వెంటనే పంపిస్తాను.
ఓకే, మీ ఈమెయిల్ కి నేను పంపించేస్తున్నాను.
ఓకే
Always I follow. Anyway, thank you for reminding me. Okay, right.
పంపించండి అయినా కూడా నెట్ ప్రాబ్లం నీ ప్రాబ్లమ్స్ ఎక్కడ అది కూడా మనతో పాటు డెవలప్డ్ కంట్రీ పవన్ కుమార్ అక్కడే ఉన్నాడా ఆయన సౌత్ ఆఫ్రికాలో ఈయన స్టూడెంట్స్ వాళ్ళిద్దరు అక్కడ ఎన్ఐటి టాంజానియా ఉంది కదా దానిలో స్టడీ చేస్తున్నారు రీసెర్చ్ ఐఎమ్ జస్ట్ సీయింగ్ blur.
Sir, Suryanarayan garu. Hello.
వచ్చింది. I got it.
Sir, అబ్బాయికి ఎలా షేర్ చేయాలో తెలియట్లేదటండి.
Okay, no problem. You have sent the PPT. We'll start sharing it.
Sir, kindly ask him to verify for audio at least.
Sir, మీకు నేను ఒక I will do one thing. I will send his phone number. Please make a WhatsApp call. How to connect? You don't know how to connect the.
Okay.
The problem is with how to start his presentation.
Okay. You can continue, sir. Thank you. అదే మీరు కొంచెం
సార్ లేకపోతే అతను ఫోన్ నెంబర్ పంపిస్తాను, కొద్దిగా ఎలా షేర్ చేయాలో చెప్పండి సార్. పాపం
చెప్తాం కానీ ఫస్ట్ పీపీటీ వీఆర్ అప్లోడింగ్ ఇట్.
ఓకే సార్.
ఆయన వాయిస్ వస్తుంది రాదో ట్రై చేద్దాం. ఆయన ఫోన్ నెంబర్ మీరు నాకు పంపిస్తే నేను ట్రై చేస్తాను, వాట్సాప్ కాల్ చేస్తాను.
ఓకే సార్.
It has come already. So and is he able to see also? You can ask him.
Sir, he is seeing, sir. Now he is getting.
Okay.
Noni, please unmute your system.
Okay. నమస్కారం. అది ఇది జరుగుతుంది కదండి, జాయిన్ అవ్వండి. ఓకే. ప్రెసిడెంట్ గారు మాట్లాడారు. సో ఇవాళ మధ్యాహ్నం జాయిన్ అవ్వండి, ఇప్పుడైనా మధ్యాహ్నం.
సార్ ప్లీజ్ చెక్ యువర్ వాట్సాప్ నంబర్ సార్, సూర్యనారాయణ గారు.
ఓకే.
సార్ సూర్యనారాయణ గారు, ప్లీజ్ చెక్ యువర్ వాట్సాప్ సార్.
ఎస్ సార్.
We should have tried out all these artists a half an hour before the program.
Sir, Sudhakar garu, is it URP Sudhakar garu?
Yes, sir.
One second. Sir, can we start Professor Pawan Kumar's presentation?
Yes, that's a good idea.
First start is Noni, sir. He's
but
waiting.
Noni voice also is not coming. That's why.
No. Maybe one of the co-authors can present.
Pawan Kumar can present it. Otherwise.
Yes, sir. Let's try that.
సూర్యనారాయణ గారు,
సార్
ఈయన ఈజ్ హ్యావింగ్ ఎ సపరేట్ లింక్. దట్ లింక్ forward to his WhatsApp so that he can.
I'm doing it, sir. I'm doing it.
You need not to join in general one. You can do that special link.
Sunaren garu, he's waiting for your link.
ఇగో లింక్ మీకు పంపించాను సార్, ఆయన పంపించేసండి.
మీకు కూడా పెట్టండి WhatsApp.
మీ దాంట్లో ఉంది లింక్.
Click same thing. Directly will come on the screen.
Mahesh has given me the link. I have sent to Prasad.
Is only link. Is only Dyson link is great link. That link only you have to forward. Either mail him or WhatsApp.
Sir, Suryanarayan garu, he's opening, sir. I sent a link. I spoke to him.
Okay.
I sent his phone number also. Please.
Sir, 1 second.
I sent one
In the
WhatsApp
meanwhile,
number.
if Pawan Kumar is available, because see what happens is all these people who are waiting, they will feel that.
Yeah. I will speak to Pawan also. Pawan is
let him start his speech. Then this Dyson we can.
Internet problem.
Yeah, I know. I understand. Now we are dealing with underdeveloped or static. Then in the afternoon we will deal with a developed world also. Let us see that.
Now he is getting, sir. I think so.
Let him start.
Noni, please start.
Okay, sir. Good morning. Can I start, sir? I'm ready, sir.
Yeah. It's good.
Okay, thank you. Good morning, sir. Good morning, all. Mr. Dawson Nyoni from Tanzania. I would like to convey my thanks to the Institution of Engineers, Institution of Marine Engineer, and the organizing committee, and the special thanks to the Professor Prasad. And I would like to convey the special thanks from my Professor Zakaria Mganirwa, Director of National Institute of Transport. He's happy for me to join with you today, and he sent a message to you that please, when you visit Tanzania, please reach us. We share, be happy when we share with you. We share with you. And NIT, we have already started the first BTech for this year. So for that reason, you're still young. We need your cooperation in a conference, workshop, and any maritime related. Please continue to cooperate with us. So we really thank you for this opportunity. So I want to go back to the presentation. Please, next slide. Yeah. As we know, the port introduction, the port is the maritime facility which comprise one or more wharves and a loading area where ships load and discharge cargo and passenger. But this this port can be categorized as the minor or major port. But for us in Tanzania, we categorize the port as a minor and a major according to the holding capacity of that per year tonnage. But for the case of India, you categorize major and minor port according to the jurisdiction of the central and the state government as defined by Port Act of 1908. For example, of minor port, but for us Tanzania, we can call as a major port is the three port which from the Andhra Pradesh, like Krishnapatnam, the port, but is located the deep water port is now option, and Gangavaram port, deep water operation, and the Kakinada port, deep water operations. Let us go to yes. Now, when we go to design the vessel, there is some mission factor which could be taken in consideration. For this one, I put some few, but we have more than that according to the mission of your vessel. Like the ship type, for us, for today, we shall discuss the one type of multi-purpose cargo vessel, and the type of cargo is unitized goods or liquid. Relevant rule can be characterized by HIMO, SORAS, MAPO, ICRAS in their registered class societies, shape of stems, shape of stem variables, and the deadweight as stated above is 1,000 tons, and the speed design or speed could be 15 knots. Let us go to another slide. Another slide, please. Now, if we say the design cycle, it means it is the concerning with the calculation from requirement, from preliminary parameters, and you go to calculation for powering, resistance, damage, stability, intact stability. We go to hurry and machinery arrangement. This will go about on these things. But now we can see this calculation. If you have we have the dead weight of the vessel, you can now start to calculate the displacement of that vessel, volumetric of that vessel, according to because you have a coefficient of mass, as you can see here. Is it ranges from 10.6 to 1.1. Yeah, and then now when you got this displacement, you got the volumetric of that vessel. Now you can go to find the length, you can go to find the breadth estimation, draft, and the depth estimation. And another slide, next slide, please. This hull form coefficient is taken from encyclopedia, and you see the range, and but in this bottom we select that we select the value. When you select this value, it will help you to show the hull form of that vessel. Next slide, please. Now we can estimate, because you have all of this one, you can get a light ship weight, you can estimate, and you can get, and when you get a light ship weight, you can get the total displacement of your vessel. Next slide, please. Now you can, if you have all of this, now you can predict, you can calculate the resistance. And for this case, for the resistance, you can use the calculation, and another side you can use a software. For the software, for now, I will use the MaxSAF software so that I can determine the resistance. Why I use MaxSAF software? Because I'm familiar with this MaxSAF software. So by using this MaxSAF software, I can get the resistance of the vessel. After getting this parameter, now I can go to another slide for the power propulsion. From this power propulsion, at the end now, when you calculate and after you calculate, and then you can see in MaxSAF software, and you can after seeing this, you can determine the efficient power. After getting efficient power from the resistance and the vessel speed, you can get the total of effective power. After getting the total effective power, you can determine by using propulsive coefficients. You can get the derivative power now. After getting the derivative power, you can determine the installed brake power. After getting the installed brake power, you can choose the type of engine according to the brake power, and you can that ship power required per engine, and select the engine must not be less than not less than, but again not much to the design speed brake power. Next slide, please. After getting this parameter, you can draw now by using MaxSAF software. You can use the geometry of the ship hull, and you can show the profile plan with the side view of the hull, brake plan, which is the view from the above, and the body plan, which is the view from in front. Intersection with the horizontal plan, the line intersection with the horizontal plan are called waterline, but the line which above the waterline is called load waterline. Intersection line which is longitudinal, which with the longitudinal plane are called backchord line, but it called line height midship. The intersection line with the vertical line are generally called station or sections. Next slide, please. This is the profile view and the brake plan view, and these are generated from the MaxSAF software. Because I have all the preliminary parameters, so I can draw the line and the body plan. Next slide, please. Now, after getting the hull form of that vessel, and after getting after getting the align, after finishing the hull form, the next step now is to make
Only first complete your talk, and then you show it later, that one.
Okay. Now we go to another for the vessel stability by using the tool. That tool we use the MaxSAF software as the nav architecture tool used to conduct the stability analysis. Now we can predict the stability of that vessel. Now we have, but this stability could be tested by IMO 749 code for intact stability and the IMO for code intact stability. The following result was plotted on the figure following. The next slide, please. As we see in the last slide, we tested this vessel into two kind of condition. One condition was the 90% full load departure condition, and another condition was the 20% of full load arrival condition. But when you draw the G-curve stability report, you see now the full load vessel stability, it vanished from maybe 179 degree. But when you see this another case, it vanished to 50. So there is a difference of 20 degree. What does it mean on this 20 degree? It seems that this vessel of full load is more stable than when you compare with the full load alive. So, and this information is supposed to be known by the port operators during the overloading and during reporting. Next slide, please. Now, okay, next slide, please. Now, after knowing this, but we go to further step with the damage stability requirement testing. We test at the compartment. We divide this vessel with the compartment. Maybe for this case, I have 7 compartments, A, B, C, D, E, A, B, C, D, E, E. So when you test this one, the floatable range of this one should be higher in the middle, so that this vessel, when this compartment B or compartment A, when will be damaged, vessel is supposed not to sink, supposed to continue. Go to another slide. Another slide, please. And this is the curve which has been drawn from the Microsoft software, which by the trim of 1 meter and the displacement of this one, and the operating condition density as we take at 1.025 ton meter cubic, and the length of the wave we consider to 130 meter, and the wave 8, because this could affect the buoyancy of the stability of the vessel is 2.121 meter. 2 sets of criteria as a minimum of freeboard of margin line shall not be less than 0 meter, or the second maximum trim angle should be not less than 15 degrees. This is the criteria. Let us go to next slide, please. Next slide, please. Yeah, the result discussion. Floatable range, 6 backhead compartment has been tested for floatable range. The maximum floating length of 1.18 meter AP at a longitudinal point of compartment. And this is near to the midship. The minimum of floating length of this was 3.5 meter at the longitudinal point of compartment. And at the permissible range is a product of floatable range of the factor of subdivided. The factor of the subdivision department of the length of this, the volume and the machinery should be taken in the consideration. Let us go to next slide, please. This is the end. This is the conclusion. For the ship design cycle can be affected the design parameter on intact and the damage condition of analysis. The ship design cycle is It may help in better location and arrangement of machinery, cargo hold, equipment, crane, wheel house, and storage, which is in use. So it is very important to start with this stage before going to the cost, because if we fail to do this one, we will read you in the ferry of the vessel. And any testing of the vessel stability must be sufficient stability for the ships to satisfy the IMO criteria, SORAS criteria for next contract and the detailed design. The damage stability are tested very casual during the design phase. And to satisfy with IMO criteria, the floatable length of the vessel vary from the point through the length, and is usually greatest midship, as we see in the last slide. So I really thank you for giving me this opportunity, and we need more cooperation. Thank you, sir. I submit.
Surnaran garu, any questions? Hello.
Audience, any questions, please put in the chat box, or otherwise you can raise your hand also. Sudhakar garu, the floor is yours. And Solanki sab, the floor is yours.
Oh, okay. Can I go first?
Yeah, please.
First of all, Mr. Dawson Yernie, congratulations for a very comprehensive paper on concept design process. Just for information, I worked in ship design for nearly 15 years. I was involved in design of ships of different types as a project manager. So I know a little bit about the whole process. The ships were actually built, what we designed in NSDRC. Now, I have a couple of observations on the paper that you presented. I've also gone through the paper, the text of the paper. Are you able to hear me?
Yes, sir. Yes, sir.
Good. Now, design is, as you know, is an iterative process. That means there's a design spiral, and you go round and round, and then you arrive at the core parameters over many iterations. Now, having said that, now when you go through iterations, especially in the conceptual design, you often come out with certain alternatives as to what you choose to do. Maybe alternative 1, alternative 2, alternative 3. So out of that, you might have chosen one. Why you have chosen one? There should be some logic. So that process is not captured of iterations and alternatives. That is one. Secondly, you said cargo is unitized cargo, and I'm assuming these are containers you're talking about. Am I right?
No, sir. It is a general cargo ship. So you can unitize, and you can call some other.
Fine. General cargo. Okay. If it is general cargo ship, my suggestion would be to go for a twin deck, because a twin deck will enable you better utilization of space. Okay.
Yes.
And also, I would suggest that you must also make it possible to carry containers, in the sense, in future, where the ship has a life of about 20-25 years, you must think of future development in terms of container being transported if required. So then you must make the cargo space multiples of 8 feet with a little bit of gap, so that it is accommodating certain number of containers. And so that if required, you can switch to containers in some of the holds or all the holds if you want. That option should be available. And you must also decide whether you want to carry the containers on the deck. It is a good idea to carry at least one or two rows of containers on the deck. So you must make the design a little bit flexible for future upgradability. So but that is one. Second, thirdly, I would like to say, when you're making a port specific design, for example, your plan from your write-up, I understand it is from Vizag, Visakhapatnam to Dar es Salaam. Okay, in that case, you must make the design highly customized to suit the port specific conditions. This is a small vessel, so that should be okay. But you must look at the draft, you must look at the other conditions, and so that you must sort of look at, I don't see that input coming in the paper, how you have made the design suitable for these specific ports. And thirdly, since it's a small vessel in the sense it's a 10,000 ton DWT, I would like to see a cargo gear. Whether cargo gear is a good option to have a cargo gear, self-discharging, self-loading option, to have your own cranes, at least 2 or 3 cranes. And then finally, I would like to make a small recommendation. You must take this design forward to go to the basic design stage. When I say basic design stage, you do the scantling, you do the midship section, you do the strength calculation, and you cross-check all these parameters once again, and then you form up the design in a way that it is possible to float tenders for the design. You call for tender when you approach the shipyard. Concept design is not adequate. You have to go up to the basic design stage. We also call it tender design sometimes. And one last observation I would like to make is, please make a general arrangement plan. General arrangement plan is also very much required, though somewhat preliminary at this stage. So that we know the location, we know the accommodation, we know the cargo space arrangement. And one question I could not find answer is the vertical center of gravity is a function of cargo density. Whether we're putting light cargo or heavy cargo. Heavy cargo is not a problem because its vertical center of gravity will be at more to the bottom. So when you're putting, because it's a general cargo ship, you're putting all kinds of cargo, and we must look at the lowest specific gravity, which will be volume driven rather than mass driven. So in that case, where will be the center of gravity position? So that will determine the metacentric height. So that is a very critical requirement for the stability. So please look at the low density cargoes that you're going to carry, which will determine the actual VCG, vertical center of gravity, which in turn will determine the metacentric height. So that's all. It's a good attempt. It's a good exercise, good learning that happens, and then it is a good case study to present for the students for the learning exercise. But there are some practical aspects which have to be looked into, and my recommendation is to take it forward to the basic design or tender design stage. Thank you very much.
Sir, good morning, sir. Nice point, sir. Due to lack of time, we are not completed the entire ship design. The second one is we have calculated each and every point because he is new about this concept, but that's why he is not explained properly. So, Noni, please note down all the points. What studies arise.
Yes, sir.
Okay.
Yes, sir.
In the next,
Sir, I can give in writing if you want. I can make a note and give the comments in writing on page.
Sir, he will find out.
Yeah.
In your next design conceptual ship, you include all these points.
Yes, sir. I will receive the note from sir, and then I will cooperate on this. So I really thank you for this comment, sir.
Thank you very much. And Mr. Neoni, one more point. When you're making any design, any conceptual design, especially, you must look at the reference vessel. I mean, no design happens from thin air. It has to be based on a reference vessel or look at a similar design elsewhere in the world. The fair play you referred to gives good data of existing ships. You must make a reference to the existing ships and try to come close or do better than those ships. Optimize. So you should have some guidance in terms of what is feasible, what has been done in the past. You must build on what has been done already and make certain refinements or improvements. That's all. Thank you.
Captain Solanki, sir.
First of all, congratulations to Dasan Nui and Professor Prasad sir for guiding him very well. And I think the chair of the session has covered the concept comprehensively. What I would like to add in here is basically the pre-design. Before the concept, there is a pre-design stage that needs to be also taken into account, because when we are designing a vessel, what is important is the capacity of the vessel, because for a given parameter, which means we are talking of depth, or you can say bend radiuses or air draft. So these are limitations of the waterway or limitations of the port that needs to be taken into account. Based on that, you're designing a vessel which is fit for that particular waterway, optimally fit for that waterway. So which can be a canal, channel, or river. So that is one. Second, which I would like, that is, you can say, the maneuverability of the vessel, because this is I would say, a handy-max vessel likely to call into riverine ports, where there will be, you can say, restricted room available for maneuvering. So maneuverability also needs to be taken into account when we are designing these vessels. So these are the two inputs which I would like to basically bring forward. And thank you.
Sir, Prasad sir and Sudhakar sir, there is a question, and it may be, in fact, for the seniors than Mr. Dawson. This question is from Ravindra Baliga. He is asking, what special design criteria required to be considered for LNG ships and floating storage regasification unit? I do not know. This could be, he must be in Bangladesh near or some other place, because we have a lot of land, and floating storage means it should be a critical area.
Yeah, if you ask directly to me, I will give you the answer. Not now. I will give you the entire thing.
You can generally tell the concept, sir, generally.
Not now, I will give you the entire thing later, sir. This is a seminar.
This is a question from one of the, spectators or whatever.
Yeah, but I will give you the entire thing later.
No, sir, Prasad sir, Sudhakar sir. What he says is, what special design criteria, you can just summarize one or two items to be considered for LNG, the liquid natural
I
gas.
know everything. Okay. Sorry.
I understand, Sunarana. But that is not my area of work. I have not done any work in that area, so I won't be able to answer that question.
Okay, that I understand. So, Mr. Ravindra Baliga, this requires a special, what you call understanding of the design techniques. And since it is also a regasification unit, maybe things have to be more, including maybe cooling or whatever, water spraying outside for cooling the entire system. So I don't think anybody can answer you. Thank you for the question. Thank you very much. There are some more questions which have come. I have issues of concern on waterways development through inland rivers. Okay, this is a separate question. Ravindra Baliga at Gmail. Okay, Ravindra, I'll give this. Okay, we'll give it. I'll give to the professor your email address. Okay. Then Wesley Pereira, issues of concern on waterways development through inland rivers and canals. Will any papers be presented on this subject today? Yes. Captain Solanki sir is typing an answer. That is sufficient. Yes. Thank you. Okay. So, with that, no, any more questions? Any more questions? Anybody? So, sir, Captain Solanki sir.
Yeah, with regards to concerns on waterways, what is there is one is that on the Inland Waterways Authority website, there are standard design vessels and the concept is available on that. So he can go through those concepts. There are basically 11 different type of vessels that have been designed through a tender process. And if he's got any concern, he can get to me on my email, which is ivsolanki@gmail.com. So I can answer his concerns on that, or with regards to waterways.
Okay. Thank you. Thank you very much. So, sir, Professor Prasad sir, Sudhakar sir.
Yes, sir.
Yes, sir.
Pawan Kumar, Professor Pawan Kumar will start his presentation, sir.
Yeah.
Okay.
He's
Okay.
ready.
Yeah. If you face any problems in screen sharing, please forward. I think you are getting it. No worry. Thank you. You can start.
Sir, good morning. Am I audible, sir?
Yeah.
Right.
Audible.
So is my screen visible?
Yes, sir.
Right, sir. Thank you. Thank you, sir.
Yes.
So good morning to the chair and co-chair and all the participants. I would like to thank the organizers of this seminar for giving me an opportunity to present my work on the noise radiated by vessels. Though the title of the seminar is on development activity of the inland transportation using waterways and canal system, the observation what I have obtained from my present research work on the ocean noise levels is that there has been a serious increase in the background noise levels of the ocean. And among the various contributors, it has been observed that shipping traffic radiated noise has been a major contributor, and which is being increasing the ambient noise levels by at least 0.5 dB per year. Now, when we are looking at development of ports, minor ports, and inland waterways, the environmental aspect becomes a very important parameter, providing a safe environment not only for the habitability of the human life surrounding to the port, but also to the marine fauna. And in one particular case of measurements, what we have carried out is the measurement of the fishing vessels radiated noise levels in the Visakhapatnam fishing harbor region, which is close to the Visakhapatnam port, and as well as close to the existence of the human life within that region. There are concerns at the international level that the development of or improving the ocean environment and also protecting the atmosphere with reduction of emissions from ships, ballast water system that is carried by ships. So there are regulations which have come up. Now we know that there are also specially protected areas which were identified at the European region where the criteria limits are very stringently laid down on the issues of emissions and ballast water that is carried out. Similarly, MEPC and IMO has also come up with certain standards on noise radiated by ships, and though they are not mandatory at the present time, maybe in the coming future, they are going to be definitely laying down the mandatory guidelines for the noise radiated by ships, and the entire design process that is being presently carried out need to be revamped in making silent ships. And one of the concept which has come out is quieting technology. So from the Indian scenario and present contribution work what we have done, I would like to present the noise or the underwater noise levels from fishing vessels and their influence on the ambient noise levels. I'll be trying to cover the basic introduction part, the importance of fishing vessel design towards the noise radiated by vessels, the deployment system that we have used, and the location where it is deployed, and a brief discussion on the results. Unlike all commercial displacement type ships, which are used for cargo transportation or passenger transportation, fishing vessels design is a unique design. More specifically to be given in, these are small vessels which need special attention. The complex design parameters involved in small vessels because of their sensitivity towards weight and satisfying the stability criteria. Unlike bigger ships where we have a flexibility in the design with the margin in the weight that can be happen, and because of the block quotient being high, but smaller the vessels, I'm of opinion that the design becomes more complex. We have to be very careful. And there is a concern that the fishing vessel aims at a design principle of having more catch, and there is always a problem with the noise that is radiated by fishing vessels, because the marine fauna do exist in the oceans because of the sound energy. Unlike heat, light, sound is the only form of energy which can be used for various number of underwater applications. Though we use it for sonar, now even communication has been technology has been enhanced in the developing communication using water. At the same time, the existence of marine life mainly for movement, finding food, or any other biological processes all involve sound, and sound has a speed of sound to be very high, nearly 4 times that of the speed of sound in air. So sound is known to be the only form of energy which can be useful to understand the oceans in a better manner. Now, looking at the noise that is radiated, it all depends on the frequency and amplitudes. So ship radiated noise always threatens the survivability and also brings a behavioral change in the marine fauna. It has been observed over the years that now when we look at the existing species, when certain research has been carried out, it has been observed that there are a lot of biological changes that are happening in the marine mammals. They are undergoing a lot of stress, deformity in their organs, and losing hearing ability is also identified to be one of a effect of the increase in the ambient noise levels that are happening. And in specific to ships, if ship is radiating large noise, then there is always an issue that the fish may either wrongly note the ship to be another mammal species, or it may move away from the noisy environment. So there is a decrease in the efficiency of the catch that can be obtained by fishing vessels if they are more noisier. So ships, fishing vessels in specific, have to be silent, and there are also regulations which have come up, like the ICS, International Council for Exploration of Sea, CRR 209 report, which has given up the standards of the noise radiated by fishing vessels. And fish hearing threshold is a very sensitive towards low and high frequencies. It has been observed that the frequencies at which the fish communicate are all mostly low frequencies, but certain say sector of fish or certain category of fish also use sound at a higher frequencies. And sound produced by fish for communication is generally associated with the vocalization, either reproduction or stressful situations. The sound generally is produced by the sonic muscles, which are located near the fish swim bladers. Rubbing together the skeleton components, they quickly change the direction and speed and swim away. So we can see that the sound is an important parameter in the marine environment, and fishes have developed sensory mechanisms for detecting, localizing, and interpreting sounds. Now, if we look at the concept design, or we call it as the design spiral of a fishing vessel, or in a general, any ship, the major concept develops with the owner's requirement. Mainly, we look at the displacement of our ships where the dead weight, the cargo weight, is an important parameter with which we start with the design spiral, starting with going ahead with the parameter selections, engine power, spacing, volume distribution, stability, general arrangement, costing, performance predictions. But in specific to fishing vessels, the cargo here would be the fish itself. So the hold space, the fishing hold space, and preservation of the fish till it is brought to the shore, it becomes an important design parameter. Now here at the international level, as indicated earlier, IMO has said in 2014, the 66 MEPC, Marine Environment Protection Committee meeting, that this is a knowledge gap area where a lot of research need to be come up, and they also funded for projects like Aqua and Sonic, which has actually helped in developing the safe environments or identifying special protected areas for noise related regions, and also developing designs which are silent, developing designs where certain criteria is laid down, and ships design satisfy the criteria, which also leads to an improvement in the marine transportation. So other important area which was identified by Sonic is on the propeller noise. Propeller noise is always identified to be a low frequency noise because of the cavitation. Though cavitation or non-cavitating propellers, there is always propeller induced noise which is at the low frequency. Say example, if I have a propeller which is rotating at say 240 rpm, then the RPS would be around 240 by 60, around 4 cycles per second, the hertz. So 4 hertz is the frequency of a propeller which is rotating at 240 rpm. And if it's a 4-blade propeller, 4 into 4, 16 hertz. So we can understand that a propeller generates a frequency of 16 hertz, which is almost less than the hearing ability of human. Hearing ability frequency range is 20 to 20,000 hertz, whereas the propeller noise is rated at a frequency of 16 hertz. So we can understand that the propeller, being a major noise source, will develop a frequency which is less than 20 hertz, low frequency. And at the same time, the other sources like machinery or the boundary layer, the flow of water around the ship, also becomes an important factor in knowing the frequencies. At the Western countries, there have been database which have been developed on the noise radiated by ships in the marine environment. At the same time, there are real-time sound maps which are being developed in the regions of the European waters as well as in the Portugal region, where ships movement and disturbance in the noise levels can easily give a identification mark of any underwater moving objects. So real-time sound maps has become one of the major thing which has come up, and other concept which has come up is the International Quiet Ocean Experiment, which was developed by the scientific communities, saying that how can we develop how can we mitigate or reduce the ambient noise levels by 2030. At least they were at the aim of reducing 3 dB noise. And one of the experiment proposed was, if I stop the movement of all ships per day, what will be the influence on reduction in the ocean noise level, and which is a huge which has a huge impact on the global economy, because transportation cannot be made zero at any point of time, but simulations can be done. We can model and develop certain simulations. As part of it, which was observed that nearly 21% of noise reduction can happen if we have no ship movement happening. And though it's a boon or ban, we can always say that during the recent COVID period, during the pandemic, where a lot of transportation has reduced drastically, from the annual report of the Ministry of Shipping in India, at least, when observed, it has been noted that nearly 27% of cargo handling by major ports have dropped down, both at inland and major seaports. So once there is a decrease in cargo transportation happening, it is indirectly related to the noise. We have developed a noise model where we have seen that nearly 21% of noise reduction has also been obtained in the Indian waters. We have been measuring the noise levels both in the east and west coast of east coast. We have been collecting data of Vizag and of the west coast of the Goa region. So our data has showed promising results that definitely the background noise levels of the oceans can be brought down. So just to give a typical noise sources on ship and also the frequencies, mainly the propeller, thruster, missionary, and the boundary layer noise, which are missionary noise and hydrodynamic noise, we can say. The red color in the graph indicates that there is a influence on the frequencies, that there is a masking effect. Masking effect can be defined as, say, suppose two mammals are communicating with certain frequencies. There is a third source of noise which is disturbing. That means two people are talking and the third person is trying to interfere and creating an additional disturbance, which causes a lot of disturbance and correct signal cannot be communicated. So this masking effect is happening because of many sources which are defined as abiotic, biotic, or anthropogenic. And among the anthropogenic, we can identify that shipping is one of the major contributors. And there are to be efforts in the near future to reduce this and provide a safer environment, not only for the mammals present over there, but looking at the environmental impact assessment. Among the sources of ship noise, we can see that the propeller and boundary layer noise are a function of the ship speed, whereas the electrical or missionary noise are not so. And coming to the hearing threshold, as per the ICS, International Council for Exploration of Seas, we can see that the upper limits of the fish communication are mostly in the lower frequency, which is less than, say, 1 hertz. You can see this is almost 1 kilohertz is 1000. So all these are less than 1 hertz, and 10 to 1 hertz is the infrasound, and mostly the prevailing limits are of this order. And we categorize the ship noise into two forms. One is the self noise, which is from the source. At the source, when measurements are taken, radiated noise is away from the source. And as sound propagates, there is attenuation, reduction in the sound propagation level because of the spreading loss, transmission loss that happens, though it may be spherical spreading or cylindrical spreading. There are mathematical models which are available to estimate the decrease in sound that happens, but it has noted that high frequency sounds attenuate very quickly. They do not propagate long distance, but low frequency sounds, like example pile driving sound, can also travel hundreds of kilometers. So low frequency sounds are more dangerous compared to high frequency sounds. And looking at the Venn curve is the typical ocean noise spectrum curve. And from low frequency to high frequency distribution, if we see, low frequency is mainly due to ocean disturbance, that is the wind and wave driven disturbances, turbulence in the ocean that has formed. Traffic, shipping traffic disturbance is from say 10 to 500 hertz. High frequency are due to the wave heights because of the increase in sea state phenomena that can occur. So we can ensure that there is a masking influence that is happening. Now, coming to the present measurement carried out in the Visakhapatnam Fishing Harbor region, we tried to geographically develop the area-wise to understand that around 24 hectares of water base is available for the Visakhapatnam Bay, Fishing Harbor Bay, which is next to the port, and it's have only one entrance for both to and from movement of the fishing vessels, and with nearly 9 jetties and accommodating over 688 vessels. And the designs of all these vessels are standardized because it's no naval architecture design aspects involved. It's all hereditary part from father to son. The design is standard designs which are available. They don't even allow us to develop new designs in that sector. But to the maximum possible extent, what we have observed, we have tried to get some data on the vessels which are there. These are the instruments that we have used. This is a hydrophone which has a piezoelectric material to measure the underwater
Mr.
noise
Pawan
levels.
Kumar, sorry, probably
Yes,
you
sir.
have to conclude quickly.
Yes, sir. Okay, sir. And these are the instrumentation used. These are the vessels that are present of nearly 13 meters long with 150 bhp engine and a FPP 3-blade propellers. One observation is that no fishing vessel had caught nozzle. This is the other fishing trawlers. We have the data processing done using the FFT. The sound signal measured is converted into FFT signal using 1/3 octave band, and the results shown some observations of the boat noise moving at full throttle developed a 158 dB related to 1 micropascal, which is reference to water, and 20 micropascal is reference to air. So around 158 is the dB level of fishing vessels, and being so many vessels present in the harbor limit, it's very difficult to bring measure the ambient noise condition, because at any point of time some of the other vessel engines generators were in on condition. So with distinct vessel operation, 135 dB was the sound level measured. The trawler main engine noise was 160 when the self noise level was measured, and auxiliary engines was 156. These are the noise spectrums, frequency versus amplitude, and we can see the disturbance that is mostly towards the lower frequency level, and the boat passing by from the deployment location showed a propeller noise of nearly low frequency noise of 160 dB, and these are the engine peaks that are developed, and other disturbances which are observed in the higher frequency are due to the water splashing that is observed close to the jetty. This is the auxiliary generator noise, multiple cylinder frequencies that can be seen at around 160 dB. This is the main engine fishing vessel noise. These are the spectrograms indicating the disturbance. First graph is without the disturbance, and second is the disturbance. The red color indicates the low frequency disturbance from the machinery. This is the standard criteria of the International Council for Exploration of Ships for fishing vessels, which limits nearly 138 dB as the limit in the lower frequency. Any fishing vessel which emits more than this can we say that it is not satisfying the criteria. Since it is not mandatory, no one is bothered, but once it is made mandatory by the statutory body, then entire design has to be modified. And we have also come up with DNV class, silent class notations for silent ships, research vessels, thrusters, when bow thruster is in operation. And these are the limits, which mostly lie between 140 to 170 dB. And we can say here that in the present scenario of measurements, the noise levels are quite high from the present design of the fishing vessels that are made with 158 dB, where nearly 20 dB more on the background levels, and there is a requirement to reduce the noise levels. And one way, what we have observed, that by putting a cot nozzle, 17% of the noise reduction can happen. Cot nozzle for this sort of FPP propellers, if made, 17% of the noise. This work was similar work was done by at laboratory level by putting a for the propeller noise was simulations and experimental measurements were done by some other researchers, where he has published that by putting a cot nozzle, 17% can be reduced. So in the same way, for the present designs of fishing vessels that are present, cot nozzle, if improved, put in, we can considerably reduce the noise levels radiated. And we can also say that these since ships are identified to be a major contributor, developing designs with concept of reducing noise at the machinery levels by sort of improving in the foundations. Floating floors is one aspect. At the same time, hydrodynamically designing the hull forms with noise reduction. Propeller designs like putting contra tip loaded propellers, hub designs with additional fin supports, putting stern flow fins to improve the flow onto the propeller and reduce the noise can be taken up as the design challenge to improve the designs and reduce the noise. Right, sir. Thank you, sir.
Thank you, Mr. Pawan Kumar. It's very nice presentation. Sir, Sudhakar sir.
Yes, sir. First of all, Mr. Pawan Kumar, it's a very comprehensive presentation about the issue of noise, and which is particularly interesting for the naval authorities. Navy is always looking for silent ships, but in my opinion, there are no silent ships. Only sail ships are
silent, sir. Yes.
Silent ships, and those days are over, more or less.
Yes.
Okay. And secondly, of course, there is question of reducing the noise. to an acceptable level. That is what the key challenge is.
Yes.
And in that connection, I looked at the paper. I read the whole text apart from the presentation. One thing is, gathering these readings in fishing harbor has got certain limitations. Okay, your area of focus should be the fishing grounds where the fishing is actually done. And as a starting point, my suggestion would be to talk to these operators and the people who are using these trawlers, the crew of the trawlers, as to over the years, over the past 10, 15 years, has there been any shift in the fishing grounds? And look at and mark them on the maps, on the charts, to know whether there has been any shift in the fishing grounds, which could have been due to this increased activity. Okay, and secondly, as you know, the biggest source of noise is the propeller. So in the fishing harbor, you got certain limitations. Mostly the vessels are alongside. And so that's why you should extend the study to cover the fishing grounds. And before you go there, you must make a survey of the operators to know how the fishing grounds have been over the years in terms of yield, in terms of location, whether there's been any shift. Okay, and now if you, I mean, to the extent they're willing to talk, sometimes they're not willing to talk, but then that's okay. But you have to find some other ways. And then also the best way would be, instead of going and measuring as a human being, if you can install a buoy or a transducer, which will collect these readings from a location or in a fixed manner and collect a huge amount of data from the fishing grounds as to what is happening. Or that will give you a better idea and much wider data, and eventually you'll end up mapping the sound mapping, like I said, in the developed countries. We'll come close to that stage. We'll reach more or less, and you should start with the fishing grounds. So that's all I would like to say. It's a good presentation to look at.
Just to add on, sir,
beginning.
As you mentioned, rightly mentioned, to identify the fishing zones, we have potential fishing zones, which are based on the satellite image, which we have collected. And we have observed that there is a shift in the potential fishing zones that is happening. Now in the Vizag region, when we have identified, the shift is happening towards the Bangladesh region. So we are farther moving away towards the deep water. And these fishing zones are basically from the satellite images based on the chlorophyll content on the surface water. But as you mentioned, that insight measurements gives us more data, and support from them is definitely required, and definitely we'll work toward it, sir. Thank you. Thank you for your suggestion.
Thank you.
Solanki, sir.
First of all, congratulations, Professor Pawan, and excellent work. You have and very good presentation. I would like to share the experience what we had with the issue of basically we call gangetic dolphins. So extensive study was done on gangetic dolphin, basically the effect due to movement of vessels. And this study was done by the Wildlife Institute in Dehradun. So maybe you can get hold of that. And based on their study, what they had, actually, I was coming to what precautions are required to reduce the noise or effect of the noise on the fishing. So what was recommended was, as you also has come out in your study, reducing the speed. The speed, especially when the vessel is passing through, there are, you can say, sanctuary. There is a wildlife sanctuary, not wildlife sanctuary. There is a dolphin sanctuary at Vikramshila. That is in, you can say, near Kalgaon. And so maybe you can do a study there as well. And so when the vessel is passing through that, the speed limitation is 5 knots. And the vessel, as again correctly, you can say, brought out by you, that there is a reduction of noise by putting cot nozzle. So there is also a requirement there that the propeller needs to be covered. They have not specified cot nozzle as such because it becomes very specific. So that's why all the designs which are there designed by DST Germany for in IWT transport for NW1 have got caught nozzle. So this is what I was just wanted to, we can say, supplement your work as well as congratulate, and maybe it will be a very good idea to do a study in the century, Vikramshila century.
Definitely, sir. Thank you. Thank you, sir.
Thank you.
Solanki sir, there is a question from Rajeswar Rao Mandwa. Any acoustic noise observers around vessel? So will Pawan,
Sir,
Professor
any
Pawan will be able to answer?
yes, any acoustic noise observers around the vessel? Sir, noise, there are no observers because ship is considered to be a source. That's a noise source. Ocean itself is an observer. So we can say as it propagates, it gets observed. But there are no noise observers.
He
There is
says
a
water
actually
jets can help.
requirement for this type of either, I think a study is being done which would sort of blanket the noises from the vessels. I don't know how far that has reached, but certain instruments will come probably that will either change the frequency level or whatever. They will basically be able to contain the noise within certain area.
Since these are non-mandatory, sir, no owner would be like to invest money on it in developing silent ships or things. Once it is made mandatory, then the entire ship design cycle has to be enhanced.
Mr. Solanki, can I say something?
Yes, sir.
Yes, sir. Please, sir. Please.
Yeah. What we are hearing today is the commercial exploitation of IWT. Though we see many benefits, but the sustainability issues are very much there. If you don't pay attention to the sustainability issues, we are going to rule out the benefits. In fact, it will be a problem to handle the issue problems created by IWT. This paper by Professor Pawan Kumar have generated many thoughts, and I must congratulate him. He is from academics. Whenever we go put any theorem, problems, or any theory, we got to support it by documentation and data. I would like to listen from him what sort of project they are taking in his institution, especially the students with more energy, innovation. They can be of many good to you. I can suggest you. So as of now, do you have any data available regarding the inland water noise pollution with us? That we have to see. And if it is not there, we'll have to have immediate effects, immediate attempt to generate the data for the future use. Mr. Solanki also suggested that shifting of fishing zone, there could be many problems. Seawater temperature, the food for the fishes, there are many, it is very complicated issue. And I don't think in India, we have any plans as of now to have an integrated holistic research in this area. Academicians are busy in publishing their paper related to this. Ship owners are ready, they are ready to exploit the resources. But these bridges between the interdisciplinary, they are missing as of now. The third thing, you mentioned the masking of ships to reduce the noise. One of the attempts were made by air masking. Professor Pawan Kumar must be aware of this. Can we have this air masking system on board fishing vessels? Will it be commercially viable because if you have air masking system installed on board, it will help you in enriching the oxygen in the river water. Professor Solanki sir mentioned about Gangetic dolphins. One of my friend, Dr. Sinha, I think he is presently Vice Chancellor of Sri Mata Vaishno Devi University, Jammu. He is known as a dolphin man of India.
Yep,
And he has done some, yes, sir. And he has done some research in this regard. So what is need today? To bring all these beautiful people together and have some time-bound project. Academy in Andhra University. I have spent 22 years in Andhra Pradesh, Vishakhapatnam. So they can take lead. Professor Prasad Garu is also here. So this and finally Waterjet I also mentioned. It helps a lot, but will it be helpful from the commercial angle? That also we'll have to see and establish with the data. Thank you very much. Wonderful presentation.
30 seconds. I won't take
Can
much
I
time.
add on something here?
Yeah, please.
Just basically, yes, sir.
Please.
Very valid point, sir. And definitely, as you say, that presently there is a, in India, not only the IWT sector, in fact, most of the disciplines we work in silos. So there is a need of integration in all the departments. Actually, the on the you can say when National Waterway 1 is getting developed with World Bank funding, there is a fund allocation for this type of study, and with Wildlife Institute or was, you can say, given certain funds or access to funds, whereby the research on the prevention of Gangetic dolphin can be undertaken. So there is a need of, you can say, hand-holding between the projects, that is with regards to inland waterways, because the development of waterways is being done with public funding. So there is a need of integration between the academia and the government policy makers in, you can say, these concerns, which are basically environment concerns. Thank you.
Sir, 30 seconds. Based on the certain observations done by many agencies, the international assessment of protecting blue water marine life has come into picture. And that from the London, office, they have told to stop the migration of the fishermen and the boats. So that's why Andhra Pradesh government 4 years back has drawn a plan to have at least 4 other fishing harbors, including Kalingapatnam. And they are designed, conceptualized, everything is on table. And maybe the government has called some tenders or not, but the fisherman community has to be protected in such a way that they don't group up and they don't bring all the trawlers at one place, create noise for others, and make their life and the future lives problematic. That is the essence. So that much I know. Thank you. So we will go to Sudhakar sir. We'll go to next person, Captain Nilesh Kalyanpur. Captain Nilesh Kalyanpur has a very important paper on COVID-19 pandemic and sea surfer, that is workers' endurance for more work. So during this COVID, people have suffered and some people have tried to do some work, but all that Nilesh Kalyanpur, whose biodata reads as follows. This is a small one, what I'm reading, it's not the full one. He started his sea career in 1991 with barber ship management, that word everyone knows. Sailed with Wallis Steamships, Canada, and World Tankers, Singapore. These are the companies. Shore-based role started in 2006 as surveyor with the Indian Register of Shipping. Was involved in survey of ships for various international conventions. Lead auditor for ISM codes and ISPS code. Formulated various training programs for surveyors in the organization. Joined Baker Hughes, a global leader in oil and gas services, as the India head for marine operations. Responsibilities include timely mobilization and optimum performance of fleet of well stimulation uh, and offshore pumping support vessels in India for the fracturing and rejuvenation of depleted oil wells of ONGC. Joined the leading Indian port management and operations organization, Ocean Sparkle Limited, in 2017. Head of operations and designated person ashore. As part of the team of Indian National Ship Owners Association, have been instrumental in preparation of many standard operating procedures for the Directorate General of Shipping, especially during the difficult times of pandemic. So he will be the right person who will describe where we are with the shipping industry at this time of pandemic.
Good
Let
morning,
us listen.
good morning, Conveyor sir. Good morning to the
Voice, sir. Your voice is cut. Mic.
Okay, am I audible?
Yes, you are audible now.
Yes, yes. Thank you. Good morning,
Okay.
to everyone.
Yes.
The chair, co-chair, conveyor, convener. So a big thank you to the Institution of Engineers India, along with the Institution of Marine Engineers, for providing me this opportunity. It is indeed a pleasure to be in front of this esteemed delegates. I will just like to share a brief short presentation on the crisis. Is this visible?
Yes, sir. Yes, sir.
Yes, it is visible.
Yes,
Yes.
it is visible. Okay, so as we discuss on the developments of minor ports for internal transport and management of regional waterways and canal systems, it is equally important to spare a moment to think about the manpower which mans these ships and transport the goods safely from one point to another. Why is it not going?
Yes, sir.
The slide is not moving. 1 minute. Okay. India is primarily a manpower supplier country. Indians man and operate the
Is it?
ships belonging.
Should I ask in the office?
Yeah. Have we moved to the next slide or?
You can see the next.
Yes, we have moved to the next slide.
Yeah.
I can see a graph. Yes. I can see a chart.
We move to the next slide.
Yeah. So India is primarily a manpower supplier country. Indians man and operate ships belonging to various countries in the world. Out of the 2 lakh plus seafarers that India provides, about 90% of these are serving on foreign flag ships. This is the size of qualified and trained manpower that is available in India.
Sir, what is distinct count and total count? I mean, what is the difference? I'm not able to.
So distinct count is, see, there is a leave and relief cycle. So the distinct count is actual people who are presently there on board. Total count means the people who may have signed off and who are on leave at that point of time.
Gone on leave. Okay, understood. Thanks.
So this is the size of manpower that is available in India. So out of this,
it's nearly 10% are working on Indian ships, 90% is on foreign flag ships. So my effort in this presentation is to present the crisis that unfolded in the shipping industry and how this was tackled by the industry at large. So in March 2020, COVID crisis hit the world. So as we are all aware, 90% of the products that we consume are transported through the ships. Although there is a rapid development taking place in the direction of automation and autonomous ships, and these are the future. However, at this day and time, it is the human race that is operating the ships of this world. While we know everything, the entire country after country went into lockdown mode, the air travels and all other modes of transport were stopped to prevent and control the spread of COVID-19. It was only the ships that were the ones which were transporting goods non-stop throughout the world. So as we all stayed at home, we all started consuming more and more products. This is one of the consumption charts of how the consumption increased in India pre-COVID to post-COVID. Although India being a largely a self-sufficient nation, this is gives the data of how much import and export was done. And this is at a global scale, how because of the import and exports, the global consumptions from Q2 of 2020, Q3, and it is continuously increasing. So people started ordering things sitting at home to prevent for purpose of social distancing, and everything was there available at a click of a button. This renewed consumption trend led to the strain across the shipping sector. So this is the data which was available with the United Nations Conference on Trade and Development. And this shows that there was a sudden and unprecedented demand in the shipping sectors. So the number of ships plying globally did not increase correspondingly because of lockdown and various measures. So the tonnage was almost the same. So this additionally led to a huge strain in the supply chain, and everything was borne by the seafarers who were the fulcrum of this global supply chain. So what did the seafarers get in return? The leave and relief cycles were affected. There was no access whatsoever to medical aid to them because everybody stopped people from shore leaves. Nobody wanted to take them off in case of any kind of genuine or regular medical checkups. And it resulted in longer working hours, higher level of scrutiny and suspicion because everybody wanted cargo, but nobody wanted the humans. So as humans, the seafarers came with their own, who had their own shares of anxieties. They were staying away from their families for a very, very long duration of time. Parents, family members, anybody could have been affected due to pandemic and they could not be home at the crucial time of this crisis. The United Nations and its agencies such as International Labour Organization, International Maritime Organization, recognized these dangers and pleaded to all the governments of the world to treat seafarers with due respect and provide the necessary recognition as key workers, so as to take utmost care of their travel and passage requirements. But very little was being done at the local levels. Not only, I will not blame any country as such, but everywhere it was the same story. Country after country were imposing restrictions on the movement of seafarers. Nobody wanted the humans. So these restrictions are still going on in many parts of the world. And they keep changing on day-to-day basis. So nobody wants the humans. So this is another thing which a glimmer of hope was started in 2021. Something people thought that things were improving. And then we had Suez Canal crisis, where a ship went aground. And then we had, because of these lockdowns and all that, we had container congestion blockades in major hubs of China, USA, and big ports across the world, where again, extra pressure and renewed pressure was exerted on the seafarer with the available tonnage to keep the supply chain running. So there were increased accidents because of this. There were groundings, collisions, and large-scale environmental pollution were attributed to the human error, which in turn was due to prolonged working hours, extended contract, and a state of depressions which these people were going through. On top of it, in order to please the local population and the local media, seafarers were subjected to criminal trials in violation of the United Nations guidelines to provide a fair treatment to the seafarers and avoid criminalization. Well, the sob story is over. The pandemic also provides an opportunity, and it has taught us how to learn, collaborate, and improvise. Never in the past have the government departments been so accessible to the common man and the industry. Every government department in India formed a crisis management cell and was accessible to the problems being faced by the industry. The Director General of Shipping, the nodal regulator of shipping in India, also formed a cell and was continuously accessible to the industry in these difficult times. Everybody stepped up their effort. The people in offices of ship owners, managers immediately got in touch with the families of seafarers and provided them the required solace and comfort, trying to find out if the families required any kind of effort. This was true for every companies. Indian companies, foreign companies, they have organizations out here, POSMA, MASA, INSA. Everybody, companies after companies reached out to the families of seafarers. As most seafarers were sailing on foreign ships, the synergy between the government and the industries ensured that the government gives permission. Never in the history of India have foreign ships which have nothing to do with India. They were just transiting. They were allowed to come into Indian ports for crew change so that they can disembark the Indian crew, the customs department, security, all the other red tapes which were there earlier. Everything was just put under the blanket, and everybody was working in synergy, making sure that things happened. During this lockdown, the ship owners, the industry, along with the DG Shipping, drew up detailed and realistic standard operating procedures which allayed the concerns of all the stakeholders together, so that we ensure that the health and safety of the seafarers were taken care of. From their part, the ship owners, in the initial period, we had to ferry people on individual cars right from one end of the country to another. So we've had seafarers traveling from north to south, east to west to join ships, and on their part, the seafaring community who were on leave, without a moment's thought, stepped up to relieve their compatriots who were there on the ships. They didn't give a thought that they have to be with their family. They stepped up and they went. They had to endure 4 to 6 days of road trips, journeys from Kashmir to Kanyakumari, from Guwahati to Mumbai, repeated stops at every borders and checkpost, hold-ups by the police and authorities, repeated RT-PCR tests 3-4 times, every time, everywhere, whatever possible, people used to have asked them to do RT-PCR test, and they did it. There were quarantines at various places, at whatever the local authorities thought fit, that was done, and the seafaring communities also stepped up to it without protest and got everything there. There are so many stories of synergies and assistance from so many quarters which helped up to avoid this kind of catastrophic moments, and embassies were working round the clock. Passports were issued when, because the seafarers were working on ships for 14, 15, 16 months. There have been cases where the passports had expired on board. Such seafarers were given passports in a few hours of request. The passports were issued by embassies. The Indian government stood guarantee for seafarers across the who were there in various parts of the world. We've never had special chartered flights, so many flights being operated from everywhere just to ferry the seafarers back to India. So such were the synergies. The seafarers on coastal vessels tugs, they helped their fellow seafarers of bigger ships by undertaking the crew change while ensuring their as well as the safety of the seafarers of the bigger ships. The government is more receptive to the requirements of the industry now. Dialogues are more cohesive and each stakeholder is appreciating the concerns of the other in the industry. A lot of surveys have been conducted by different governments as well as ILO, IMO, and being deliberated at the United Nations with the focus on the mental health and well-being of the seafarer. The stress being faced by the seafarer being away from home for a prolonged duration of time has led to a lot of psychological state of depression and anxiety and has had a long-term effects. The advantage of serving on a coastal vessel is that the contractual periods are not extended perpetually indefinitely, and the seafarer is virtually in touch with his or her family on a day-to-day basis. In case of any emergency at home, the seafarer can always be with his family at a very short notice. To some extent, this advantage is partially offset by the risk to the seafarer on coastal vessel to his own individual health due to constant and frequent exposure to the shore and port personnel within the port. The seafarer on an international voyage gets comparatively longer sailing periods and are within the bio bubble, wherein their exposure to the shore side people are little less. So while the doctors, administration, and the care workers have rightly been recognized globally for their respective roles in prevention and control of this dreaded disease and ensuring the smooth functioning of the society at large, the common man does not understand and appreciate the crucial role of a seafarer in the day-to-day life. As a seafaring community, we have to spread the word around about the contribution of the silently working seafarer. As we embark on our mission to develop the waterways in the hinterlands of India, it is of paramount importance to consider the health, well-being, working condition, leisure, and other supporting infrastructures of this most crucial aspect of the supply chain. With this, I would like to once again thank the organizer and the delegates for patiently listening to me. Thank you very much. Jai Hind.
Thank you, sir. Thank you, Captain Nilesh Kalyanpur. Sir, Narsimha Sumant Bayankar. Sir, are you online? Did you join? Were you able to join? Sumant sir? I think he couldn't join. Okay. Sudhakar sir, any questions?
Yes, sir. Yes, sir. Yes, Captain Nilesh. It's a very interesting story of impact of COVID on seafaring community. Being an ex-seafarer myself, I fully appreciate the kind of difficulties that have been faced by the seafarers and the human cost of COVID by the people who are at the forefront of logistics chain, global logistics that are handled by the shipping industry. It's a very interesting story, and it doesn't happen. Hopefully, it doesn't happen every now and then, but it's a very unique story. My question is, That one or two observations. First of all, this kind of situation brings a lot of psychological stress or emotional stress on the individuals. So have there been any measures taken by some of these operators or ship management companies, the larger ones, to sort of provide counseling, proper counseling and guidance, and help them psychologically, emotionally to cope with this difficulty by any of them? Have there been any instances to your knowledge? That's one question. If you want to respond, please go ahead.
Yes, sir. Yes, it's a very pertinent question. Yes, a lot of companies have done it on individual basis. They have had tie-ups with psychological centers to provide counseling to the seafarers. But these are all individual dependent, company dependent.
Right.
At government and at the world level, the IMO is deliberating it as we speak. And there is a paper also being discussed by various countries to make it mandatory, so that once it is mandatory, it will become a part of PSSR course, where people going out to sea will have to undergo a psychological counseling, and it will become a mandatory thing. But of course, that will be sometime in the future. The papers are being discussed, and India is very actively participating in that paper. But it will become mandatory very soon. But at this point of time, it is largely up to the companies, and most of the companies have set it up on an individual basis.
Thank you, sir. Thank you very much. That seems to be one learning that happened from this pandemic, and probably it will be structured and built into, like, shipping industry is known for that. It is very quick to convert into regulatory requirement and a training requirement too. So
Yeah.
probably that will happen over a period. And I think the shipping industry will show the way for the rest of the world as to how to go about in dealing with situations like that. And I also have a related question, which is slightly off the tangential to the issue. Have there been any demand or any attempts to increase the salaries of the seafarers who have been asked to continue on board beyond their tenure? And have there been any allowances, like you have war zone allowance, for example? Have there been any pandemic allowances that have been offered by any of the operators? Because ultimately the owner understands the language of dollars more than anything else. That's what my experience shows. Yeah.
Yes, sir. For very pertinent question. Yes, many ship owners, because as everybody would be aware, this increased boom in shipping, the freight rates have gone up. Every owner has made profits, and in turn they have shared this profit by increasing the salaries of the seafarers who have stayed on board for much longer duration of time. But one part is about increasing the salaries and bonuses. That is the commercial aspect to it. But a bigger aspect was that by law, the Maritime Labour Convention does not allow contractual period in excess of 12 to 14 months. So there were some this thing, but again, ships were also getting detained because seafarers were not signing off. So this was a chicken and egg story where people are not allowed to sign off. At the same time, ships are getting delayed and held up in detained. So yes, there was commercially, a lot of companies have compensated to the seafarers, but compensation was one aspect of it.
Sir, thank you very much. And once again, congratulations on bringing up such a structured and well-detailed paper on a very topical issue. Thank you.
Thank you. Thank you so much.
First of all, many thanks for sharing the insight into what happened in the, you can say, background to make things move during the COVID times. And I would also like to many thanks to the seafarers who have been at the forefront. At the same time, thanks to the ministries, Government of India, DG Shipping, and volunteers, as well as some of the administrators who were working during these times without any limitations of time. And so that's one. Second is I want to know, is there any additional insurance cover for the effect on the seafarers due to COVID? Because there have been after effects of COVID, especially who have been seriously critically ill with lung infections, because they are actually not you can say the effect can be a long-term effect, which can run into years. So is there anything on that front? Any idea if you have? That is one.
Yes,
And
sir.
second is so just a linked question to medicines, because on one of our batchmates and students group, because I was involved in teaching for long at ARI. So in that groups, I come across a number of cases where on ships they do not have medicines, simple medicines like paracetamol, so anything has been done on that count? I mean, has anybody had a look at the medicinal chest changes on board? So these two questions I have. Thank you.
Thank you, sir. So the first question, I will take it first. So as the pandemic struck us, as ship owners, everybody was concerned about because there were so much uncertainties. If there is a hospitalization, if transportation, travel, after effects. So all this was taken up by the ship owners with their P&I clubs. And initially, some of the insurance companies said that a separate insurance is required. But then a general consensus prevailed, wherein they said that there is no extra insurance required. Everything is covered in the existing P&I. So there was a clarification. The P&I clubs across the world, the big ones, said that there is no additional cover. It will be covered, or any kind of illness under COVID or pandemic related will be covered as part of the regular P&I of the vessel. So that was the first part of the question. And the second part, wherein I'm sorry, I didn't get the second part very clearly.
Basically, the problems of medicines,
medicinal chest, sir. There is a minimum requirement of medicine to be carried on. Indian government also has the minimum medical chest requirement. So they have again reinforced the fact that the medicine chest needs to be kept on board. For coastal vessels, there is a slight reduction because the travel and sailing period is quite low. But companies have now evolved, because those were the mandatory guidelines earlier. Now, most of the companies have got tie-ups with telemedical centers, and I can speak for my company. We are spread across India. We have tie-ups across hospital chains in India. So in case anybody has any kind of issue, we do not, like in earlier days where the ship's captain and second officer used to prescribe medicines. Now we've got expert doctors at a call away. So immediately it's connected to the hospitals, and you get a proper medical advice. And there is a minimum set of medicines which are maintained on board. Of course, the painkillers and all the controlled drugs are not kept because of regulatory restrictions, but general medicines are kept on board. And some of the smaller ships may not have, but then they are very, very close to the port. So medicines can be supplied at a very, very short notice.
Thank you. Thank you very much. Thanks, sir.
Thank you, sir.
So, Chairman, sir, Brahma Reddy, sir, Venkat Subaya, sir. Sir, we have finished the papers for the day, and we can go for the lunch and return back at 2. p.m. sharp.
Okay, thank you, sir. Thank you for the excellent speeches by Dausan Nani and Professor GVV Pawan Kumar and Captain Nilesh Kalyanpur, and really excellent replies and suitable and very this one replies given by the Nilesh Kalyanpur. And Sudhakar sir, the chair of the session chair, and the co-chair, Captain Indravi Solanki, they analyzed the today's topics. The lecture also analyzed, and they have made it clear to everybody. And thanks for the Dausan Nyani for coming all the way from Tanzania and involving. And we really see you further in future also. You can bring even other branches of engineering into our fold, because this is a world-class professional body having presence in 125 centers in India and 8 chapters abroad, and also 31 professional bodies are have a MOU with the Institution of Engineers India, and the largest professional body in the world, having a 8 million, 0.8 million membership as a corporate members. So this is for your good information of Mr. Daushan Naini. I'm happy that you have studied in Andhra University, MTech and NIT Warangal. And really, sir, we appreciate your speech, and then the way you have expressed and presented the things. It was really wonderful. And it all credit also I would like to give to our convener Suryanarayan Garu to bring you into our fold, and our Marine Engineering Division Board Commander Dr. Bhaskar Bandarkar sir, and all the speakers. And I don't know, I think first time I am attending a marine engineering program in my lifetime, I can say, and so excellent, and so far so good, and nothing further we can, there are no words to say, is because I have gone through, I attend almost all the branches of engineering, and wonderfully it has covered, and a subject is also, you have all selected very good subject, though it is a design part of today's topic, and we really enjoyed, and I think all our participants also will agree with me, and Nilesh Kalyan Purzi and explained very nicely about the seafarers, workers, all the issues, and then radiated underwater noise from fishing vessels, and all. Our Professor GVV Pawan Kumar from the Visakhapatnam also explained wonderfully to everybody, sir. And I really thank all of you to be part of this program, and hats off to all of you, and on behalf of the Telangana State Center and on my own, I thank you all of you for participating again in this, and as we are now discussing for the lunch, I hope after lunch also the session will be very interesting and inspiring, and all the morning session was really very inspiring, and the way the Sudhakar sir chaired, and then Captain Indravi Solanki, and really, sir, thank you both of you also, sir. Thank you very much, and I think as Suryanarayan Garu announced, we will go for a lunch and join 5 minutes before 2 p.m. Thank you, sir. Thank you all.
Thank you.
Thank you, sir.
Okay, sir. ఆర్కేఈసి రాధాకృష్ణ అయిపోయి చెప్పాడు, ఏం అడగలేదు, ఏమి ఇవ్వాలి అని అడిగాడు. ఇప్పుడు దీనికన్నా అడిగితే 30,000-50,000 ఇచ్చేస్తాను, నేను చేస్తాను ఇంకో 4 నెలలు పోయాక, అప్పుడు ఇద్దుగాని 3 లక్షలు 5 లక్షలు ఇద్దుగాని. So he has agreed me. So we'll plan in the next 6 months. ఇంకో ప్రోగ్రామ్ వెయ్యాలి, చేస్తేనే కొద్దిగా బెటర్గా ఉంటుంది. నాదా నాది మ్యూట్లో లేదు, వెళ్ళిపోతుంది. కరెక్ట్. ఓకే, డిస్కనెక్ట్ చేయాలి. Good afternoon, madam. I'm we will start exactly in 30 minutes. Not yet, sir. Not yet.
Professor
Yo.
P.S. రాత్రి అది ఎస్టర్డే
నిన్న మీకు పోస్ట్ చేశాను కదా. భోజనం చేయలేదు కదా.
చేస్తున్నాను
మీరు